Let's look at compositions involving inverse trig functions. For example, let's find the exact value of tangent of inverse cosine of square root of 3 over 2. So let's let y equal this angle here. So y is equal to inverse cosine of square root of 3 over 2. And if this is y here, then we're looking for tangent of y. So if y is equal to inverse cosine of square root of 3 over 2, that means that cosine of y is equal to the square root of 3 over 2, where y is in the interval from 0 to pi. Remember that when computing inverse cosine values, our answers must lie in this interval 0 to pi. Thinking of our unit circle, and remembering that the cosine is the x-coordinate of the point of intersection of the terminal side of the angle and the unit circle. And we know that the terminal side of the angle pi divided by 6 intersects the unit circle at square root of 3 over 2, 1/2. Therefore, the cosine of this angle is root 3 over 2. And moreover, it's the only angle in this interval whose cosine is equal to square root of 3 over 2. That is, y is equal to pi divided by 6. And therefore, tangent of y is equal to tangent of pi divided by 6, which is equal to y divided by x, or 1/2 divided by the square root of 3 over 2. And the 2's will cancel, which gives us 1 divided by square root of 3. And then rationalizing gives us our answer of square root of 3 divided by 3. All right, let's look at another example. Let's find the exact value of arcsine of cosine of 4 pi divided by 3. Well, what is cosine of 4 pi divided by 3? Well, thinking of our unit circle, the terminal side of the angle 4 pi over 3 intersects the unit circle at negative 1/2, negative square root of 3 over 2. And the cosine is the x-coordinate of this point here, or negative 1/2. So therefore, this is equal to arc sine of negative 1/2, which is equal to negative pi divided by 6. Because remember, y equal arc sine of negative 1/2 is equivalent to sine of y equal to negative 1/2, but moreover, y is in the interval negative pi halves to pi halves. And thinking again of the unit circle, we know that the terminal side of this angle, which is 7 pi divided by 6, intersects the unit circle at negative square root of 3 over 2, negative 1/2. But also the terminal side of this angle here, 11 pi divided by 6, intersects the unit circle at square root of 3 over 2, negative 1/2. Which means the sine of both of these angles is equal to negative 1/2. Because remember that the sine is the y-coordinate of these points here. However, neither of these angles lie within the restriction of arcsine. So what we need to do is determine the angle that's coterminal with 11 pi over 6 lying in that interval, which is this negative pi over 6 up here. So this is our answer. And this is how we work with compositions involving inverse trig functions. Thank you, and we'll see you next time.